Subscribe our channel, press the bell icon for latest videos.
Hello friends, here in this video we are going to see a problem on torsion. For that, here is the question. I'll read the question and write the data along with that so that we can simplify the problem. So let's get started. Here it is given, design the diameter of the solid circular shaft. In the data, first mention the type of shaft. Here we have a solid shaft as mentioned in the question. To transmit 50 kilowatt power is given, denoted by P. Multiplying the power with 1000 or 10 raised to 3 to get in terms of watts. Next, rotating at 100 rpm. Speed of the shaft is given. Maximum torque is likely to exceed mean torque by 25%. This relation can be written in this way, that the maximum torque T suffix max is 1.25 times of T mean or T average. Next, maximum permissible shear stress is 60 megapascal, that is tau. It is 60 Newton per mm square. Next, because megapascal is same in terms of Newton per mm square, also calculate the angle of twist. First they have told us to design the diameter, means we have to find the diameter, and now it is said in the problem that also calculate the angle of twist, which is theta. For a length of 2 meter, the length of the shaft is given. Mm by multiplying it with 1000. Next, take G, which is the modulus of rigidity, 80 GPa. So it is 80 into 10 raised to 3 Newton per mm square, because 1 GPa is 10 raised to 3, that is 1000 Newton per mm square. Now, since power and RPM are given, I'll use the formula of power and get the value of torque. So in the solution part, since the power transmitted by shaft is given by, it is given by the formula P is equal to 2 pi nt upon 60, and in the formula of power, the torque which is there, it is the mean or average torque. So therefore T on one side, that is T mean, is equal to P into 60 divided by 2 pi n. Next, P is 50 10 raised to 3 multiplied by 60 divided by 2 pi into n. N is 100 rpm. So from this I am going to get the value of T mean, and it comes out to be 4774.65, and as power is in the form of watts, torque would be in terms of Newton meter. Now, after getting the mean torque from the power formula, I'll get T max, and that T max is 25% more, so it is 1.25 times of T mean, and maximum torque would be there in the starting, that is if we are starting the shaft from a rest, at that time it would be the maximum torque, whereas when the shaft is running continuously, in that case it would be average or mean torque. So T max is always greater than T mean or T average, so this would be 1.25 times of the value of T mean, which is 4774.65, and here T max comes out to be, it is 5968.31 Newton meter. And now, as we want the diameter first, and diameter should be in terms of mm, this torque needs to be converted in terms of Newton mm. So to replace meter with mm, multiplying here with 1000, and it gives me the value as 5968 0.31 into 10 raised to 3 Newton millimeter. So this is the value of torque. Now this torque would be used in the problem, that is, since tau is given, Tmax I have found out, I can simply use the strength criteria to get the value of diameter. So next is I am using the strength criteria, that is by strength criteria, which is given by the torque in the strength criteria is the maximum torque. So it is Tmax upon J is equal to tau upon R. So therefore Tmax, I'll put the value, it is 5968.31 into 10 raised to 3 Newton mm. J for a solid circular shaft, it is pi by 32 d raised to 4. Tau is given 60 Newton per mm square. Radius is the half of diameter, and after the cancellation I'll shift d cube on one side because I have to calculate the value of d. So therefore pi by 16 into 60, d cube is onto the other side. So after the calculation and getting the cube root, the diameter comes out to be it is 79.72 mm. So that's the first answer. And once the diameter is known, I can draw the diagram of the solid circular shaft indicating the diameter over it. It is 79.72 mm, and this is the solid circular cross section. So first answer. The next part of the question is we have to find theta, that is the angle of twist. For that I would be using the rigidity criteria, just in the same way as I had used the strength criteria. So from rigidity criteria, again Tmax upon J is equal to g theta by L. This is the rigidity criteria, because here we have modulus of rigidity and even angle of twist theta. So therefore here Tmax is 5968.31 into 10 raised to 3. Then J for a solid circular shaft is pi by 32 d raised to 4, and here the d is 79.72 is equal to G value is given, that is 80 into 10 raised to 3 Newton per mm square, and theta is what we have to calculate here. Length of the shaft is 2000 mm. So when I calculate over here, I am getting the answer of theta, which comes out to be 0.0376 radians, because at first the answer would be in terms of radians. Next, to convert this into degrees, multiplying this by 180 and dividing it by pi, so I am getting theta as 2.15 degree. That's the second answer, and both the questions have been solved, that is the diameter and the angle of twist. So with this, the problem gets completed.